In this video, we will explore arithmetic sequences, its definition, and examples. For the second example, we're going to find the general equation of this sequence, 13, 9, 5, 1, negative 3, using the general formula, which again is a sub n equals a sub 1 plus d times the quantity of n minus 1. Here, a sub 1, the first term in the sequence, is 13. Now we want to determine what d is. Between 13 and 9, I'm going smaller. The numbers are getting smaller. 9 to 5, smaller. 5 to 1, 1 is smaller than 5. So that means that I'm subtracting some common difference. 13 minus 9 gives us 4. So let's try negative 4. 13 minus 4, of course, is 9. 9 minus 4, 5. 5 minus 4, 1 minus 4, negative 3. Therefore, our common difference is negative 4. From here, we're going to substitute the values into our general formula. So that gives me a sub n equals a sub 1 is 13 plus d, which is negative 4, times n minus 1. So we have 13 minus 4n. Negative 4 times negative 1 gives us a positive 4. So our general equation for this sequence is a sub n equals negative 4n plus 17. Again, I'm going to do a simple check just to assist us with understanding this. So this is the first term, second term, third term, fourth term. Let's go with the fourth term. So this is a sub 4. If I want to check this with a sub 4, I'm going to substitute 4 into this equation because, again, n gives us the position, and we're in the fourth position of the sequence. I have negative 4 times 4 plus 17. Negative 4 times 4, negative 16 plus 17, which leaves me with a sub 4 equals 1, which is what we have here. Now we have an example where we're given the first term of the sequence and the common difference. A sub 1 equals negative 23, d equals 7. Using this information, we are to determine the first 6 terms of the arithmetic sequence. So we're going to start by naming the first term, which we know to be negative 23. Using the common difference and applying that to the first term, it will give me the second term. So a sub 2 is simply negative 23 plus 7, which gives us a negative 16. So a sub 2 equals negative 16. And then a sub 3 equals negative 16 plus 7, which gives us a negative 9. A sub 4 equals negative 9 plus 7, which leaves us with negative 2. A sub 5, I simply take my term from a sub 4, which is negative 2, and I add 7, giving me 5. And then a sub 6, I take a sub 5, which is 5, and add the common difference of 7 to get 12. So a sub 6 is 12. Now I have each of the first 6 terms in my arithmetic sequence where the first term was negative 23 and the common difference is 7. From that, I would like to be able to determine the general equation for this particular arithmetic sequence. Now, I already have the information that was given earlier, the first term and the common difference, so I am going to use the general formula again, which is a sub n equals a sub 1 plus d times the quantity of n minus 1. I'm simply going to substitute the information that I know. A sub n equals negative 23 plus 7 times the quantity of n minus 1 negative 23 plus 7n minus 7, which gives me a sub n equals 7n minus 30 as our general equation for this particular example. If you want to check, you can do as we did with the two previous examples just to ensure that you have the correct general equation for this particular arithmetic sequence. For the final part of this example, we are going to find a sub 100. Now that may seem like a lot considering we just added 6 to each of the previous terms to get the next term, but we're actually not going to do that here. We are going to use the general equation that we developed earlier. Recall that we found a sub n equals 7n minus 30 to be the general equation for this arithmetic sequence. Now, using that same equation, we will be able to figure out what a sub 100 is. So instead of a sub n, we're going to actually write a sub 100. Again, n is the position, so we're in the 100th position or looking at the 100th term. So we're going to actually substitute 100n for n and subtract 30. 7 times 100, 700, minus 30, we have 670 as the 100th term of this sequence.